when we look at all of this data, oh, our culture, our civilization is just doing everything wrong. Everything has been done wrong, but it's not difficult to switch and do everything right. The problem is to force our politicians to do that.
Hello, everyone, and welcome to today's Climate Emergency Forum. My name is Regina Valdez, and I am the Program Director for Climate Reality Project, New York City. I'm also a trained climate reality leader and mentor. I'm a lead Green Associate and a Green Faith Fellow. And today, as mentioned, we'll be speaking about our oceans, climate, and crisis. So I want to share with you the very important SDG, or Sustainability Development Goal, number 14, life below water. And this development goal is to conserve and sustainably use the oceans, seas, and marine sources for sustainable development. This goal is to be fully implemented by 2030. And I wanted to quote our Carl Sagan, who says, "It is incorrect to refer to planet Earth. It is ocean." And indeed, 71% of the Earth's surface is comprised of ocean. So really, we're planet ocean. Antarctica, which is liquid in a frozen form, is 2.75% of the Earth's surface. So when we're talking about life below the sea, we're talking about the greater portion of life on our planet. I want to share with you this article that I read the other day in the Washington Post. It was about this sailor who fell overboard, and he was clinging to this, as they called it, sea rubbish for 16 hours and survived. I read this article and then I read the comments, and it was really interesting to me that in all of the comments, everyone was talking about how heartwarming it was that this man was able to survive and how it was, really lucky for him. And really no one mentioned the problem of the rubbish. And indeed, this man said that he left it floating just in case someone else fell overboard and needed it. And this here is a really big problem that we're facing. And it's, I hate to get too deep, but it's like this sense of the primacy of Homo sapiens over all other living beings. And as mentioned, there are more living beings in the ocean than on Earth. So we really need to think about our perspective and what matters. So in terms of life below the seas, we're really looking at a terrible situation when fishermen consider this a day out fishing. There's nothing sustainable about this whatsoever. And it doesn't in any way lead us any closer to reaching SDG 14, protecting life below the sea. What's extremely problematic about this is that these commercial fishing vessels go out. They have these long trawlers that just collect fish. And you know what's problematic is they have all other kind of species. They're called bycatch. And when they are caught, they often stay on these boats to die, and then are simply tossed overboard like so much sea rubbish. But these huge vessels get billions and billions of dollars on subsidies every single year. Why are we subsidizing something that is destroying our planet? There's nothing sustainable about this. This is not where subsidies should go. We should not be paying for these vessels to be decimating life in our oceans. I mean, look at this poor sea turtle. So it would take 67 ships an entire year to clean up less than 1% of this sea trash or the sea rubbish. And I want to point out that of all, we're really one ocean, but they're broken down into categories: North Pacific, South Pacific, North Atlantic, South Atlantic, and so on. If we look at is the greatest abundance in life in the oceans? We're going to be looking at the North Pacific. So when we're talking about trash in the North Pacific, we're really talking about ecocide on a mass level. So in terms of overfishing, I want to talk to you a little bit about the law of the sea. So the law of the sea indicates that these giant fishing vessels can ship up and can fish up to 200 nautical miles from the shore. So say, for example, this is Eastern Canada. Canadian vessels can fish up to this area. But then after this area, it's anyone's game. Anyone can do what they want. And the law of the sea dictates that, hey, if someone from Japan wants to catch whales out here, it's fair game. So again, we have north, south, and all of these various latitudes, but we're really one ocean. I just want to quickly touch upon the temperature changes that we're seeing within our ocean because this affects sea life in addition to overfishing. Look at the raising temperature in the South Pacific. The North Pacific, if we see this band, we can see the ecocide perpetrated. And then what's most horrifying is, as I said, most life is concentrated in the North Pacific, which is adjacent to the Arctic. So if we look at what's happening in the warming of the Arctic, we truly see an absolute disaster. Quickly, what can we do? End fishing subsidies, limit the size of fleets and fish catch, and penalize illegal fishing and dumping on the high seas. So thank you very much for listening. I appreciate having your attention. And with that, I would like to turn our attention to Dr. Peter Carter. So Dr. Carter is a medically qualified doctor with a background in environmental health policy. He's the director of the Climate Emergency Institute, and he is published on environmental health, climate change, and biodiversity. He's an IPCC expert reviewer and co-author of Unprecedented Crime, Climate Science Denial and Game Changers for Survival. He's also presented in panel discussions at COP25 in Madrid with both Paul and myself. So thank you.
Thank you very much. And thank you, Regina. And just want to repeat and stress the fact that we, as you started off, that we are indeed ocean planet. And it's very hard for us to become aware of that. Even the scientists acknowledge that they have been pretty late in bringing the oceans into the climate change assessments and debate. So it's very important for everyone on Earth to be aware that really it's the oceans that are in charge. The oceans are the ultimate determinant of the climate. They're actually, if we consider the average of 2 miles plus depth of the oceans as an ecosystem, as habitat for most life, as you say, that's 99%. So the oceans are 99% of the planet's living space. The oceans are by far and away, the largest component of the climate system. And what we are causing, mainly with our fossil fuel emissions and pollution, we're causing climate system destruction. And I meant to say climate system disruption, but in actual fact, I think it's better to say nowadays that it's destruction. We're truly destroying our oceans at a rapid rate. So to introduce the latest science, there's a paper that was published this month, a dramatically important paper entitled The Quiet Onset of Ocean Tipping Points. Now, there are a lot of tipping points in the Earth system, and most people are involved in climate change are well aware of those. But this breaks new ground. This paper it introduces the triple assault, the three deadly evils that we are causing in our oceans, namely ocean heating, ocean acidification, and ocean deoxygenation. And the paper looks at those and sees that there is a relative variability of how those three interact in the ocean regions. And a lot of those regions are approaching a tipping point in which the heating cannot stop, it becomes irreversible, whereas the ocean acidification cannot stop, it becomes irreversible. And any of these tipping points which affect the ocean is pretty well end game for life on Earth, for the planet. Because, of course, as we're often reminded by the ocean scientists, the oceans don't need life on land. They don't need life on land at all. But life on land is completely dependent on the healthy functioning of the oceans. So I just want again to stress that the problem is primarily burning of fossil fuel energy that is destroying, wrecking the oceans. Most people are probably aware of ocean acidification, but there are these other two aspects as well that are just as damaging, just as bad. And there was an article, an excellent article published by an environmental professor saying we have to ban fossil fuels, and here's how to do it. So plastics, right? This huge problem in the oceans that's quite rightly getting a lot of attention. Well, it's interesting if we ban fossil fuels, and we have to ban fossil fuels, if we are going to slow ocean heating, stop ocean acidification, and slow ocean deoxygenation, well, we'll end plastics because that's a petrochemical industry. So we have this terrible situation in which we're wrecking the planet today. All we have to do is to switch over, and we can readily do that. Everybody realizes that now. We don't need fossil fuels. We can switch over 100% to clean, renewable, everlasting energy. And then our oceans can slowly recover. It will be slow.
Thank you so much, Peter. I really like that you said ocean destruction as opposed to disruption. It's really closer to the truth. Um, it's going to be, it seems as though it's going to be really tough. The petrochemical industries are just, they have this death grip. And what do you see as the answer for the end of plastic? I mean, certainly we can see that fuels hopefully are on their way out, but plastic seems here to stay.
Yeah, the supposedly great advantage of plastics, like supposedly the great advantage of the most toxic chemicals there are, is that they last forever. But that's no good for living on the planet, to produce artificial new things that last forever. And of course, the plastics are decimating the fish, right? They're literally choking on plastics. And this includes chicks, you know, chicks born on the land, and they start into the oceans. So fossil fuel industry has to be stopped, and we have to do it. We have to ban fossil fuels.
Thank you so much, Peter, for that. We're now moving on to Paul Beckwith, who is a climate scientist and is taught at the University of Ottawa in the Laboratory for Paleoclimatology, as well as at Carleton University. He has degrees in engineering and physics and has also studied physics and climatology at the doctoral level. Without a doubt, Paul is one of the most prolific climate change educators on YouTube, with more than 1,000 videos pertaining to climate science and extreme weather events. Paul, I'd like to hear what you have to say on the topic of oceans in crisis.
Well, thank you, Regina and Peter. You guys have done such a wonderful job. What else is there for me to say? But, basically, the 93% of the heating on the planet is heating of oceans. It's only that 7%, the last 7%, that heats the atmosphere, which is where almost 100% of our focus is on. We live on land, and we tend to just ignore the oceans at our peril. Of course, the equator gets most of the heat from the sun, and that heat transfers to both of the poles. And that sets in motion movements of fluids. So in the ocean, it sets in motion the ocean currents, like the Gulf Stream, for example. And they carry about 1/3 of the heat energy from the equator to the poles. 2/3 of the other 2/3 of the heat energy that's transferred to the poles is via the atmosphere. And that portion sets up the jet streams. And because the poles are warming so much faster than the rest of the planet, the jet streams slow down and become wavier. And the ocean currents, the Gulf Stream, also slows down. And that has significant implications. When the jet stream slows down, it becomes wavier and the ridges go high up into the Arctic, transferring tremendous heat there. And the troughs go very, very far south. Just think of the cold air from the Arctic that went down into Texas. So this accelerates the warming of the poles, which has huge implications, especially on the Arctic. Now, getting back to the Gulf Stream, the Gulf Stream has actually been slowing down and significantly slowing down in the last decade or so. And this slowing down has tremendous implications. The drop is at least 15% slowdown. And the Gulf Stream is very important for carrying heat northward and eastward over to Europe. So areas of Europe that are relatively high latitude are warmed up significantly by the Gulf Stream. And this whole ocean conveyor system is called the AMOC, or Atlantic Meridional Overturning Circulation. And because the Gulf Stream isn't carrying so much heat across the Atlantic, we have what's called a global warming hole. There's a massive cold area south of Greenland that's been persistently there. We call it a global warming hole because it's actually experienced cooling over the last few decades. And this is a good indication that the Gulf Stream is slowing down. Also, when the Gulf Stream slows down, more of the water overrides the continental shelves off the US, and that's caused accelerated sea level rise off the US coast. It's about 4 times the global average. The global average is about 3.4 millimeters a year. So it's about 3 or 4 times higher off the US coast. Also, the oceans are vital in the climate system. We get these El Nino and La Nino events. So in 2020, we set a global record of high temperature of 1.25 degrees Celsius relative to the 1880 to 1910 average. And that was in a La Nina year, which is generally a cooler year. The previous world record in 2016 had a very strong El Nino to push it along. So the oceans are not just warming at the surface, but they're also warming to great depths. And warmer water cannot hold as much dissolved gases. So less CO2 is being absorbed in the ocean. So the sink is reduced. The sink of carbon is reduced. Also, less oxygen can be stored in the water both at the surface, and we're getting dead zones where there's no oxygen below, which harms all of the fish. So we have huge problems. We cannot ignore the oceans. We ignore the oceans at our peril. Thank you.
Thank you so much, Paul. It's very interesting. I think a lot of people are just simply not aware of how much impact the ocean has on our climate. I've heard a lot about the Gulf Stream and what's happening there, but if you can just explain just a tiny bit, are you saying that this is a feedback effect, that the warming atmosphere is warming the ocean and the warming ocean is responsible for, then again, atmospheric changes that we experience here on land?
Well, as you mentioned in the introduction, the oceans comprise about 71% of the land surface. So the incoming solar radiation it hits the land and is absorbed on surface. More darker surfaces absorb more, but the oceans are very dark in general. So they absorb tremendous amounts of solar radiation, which heats the surface, and then the currents and the movements of the water in the vertical up through the water column bring the heat deep down into the ocean. So the warming of the oceans is enormous, and because water, of course, has a huge effect on climate. The oceans have an effect. If you live on a coastline, you have a more moderate climate than if you live in the middle of a continent. So any changes in the oceans is being transferred to changes in the overall climate.
Thank you for that explanation. Peter, I'd like to hear what you have to say on the topic.
We're really talking about the most important thing and the most desperately terrible situation that our fossil fuel industrial civilization has brought about. And that is the severe degradation and destruction, intentional destruction. Regina mentioned the terrible effect of the massive trawlers, right? That plow, they're plowing the seabed. There's nothing more important for life, of course, than the seabed. And that's also disturbing another factor, which is disturbing the capacity of the ocean to retain the carbon, which falls down to the seabed and is incorporated. So, unfortunately, when we look at all of this data, our culture, our civilization is just doing everything wrong. Everything has been done wrong, but it's not difficult to switch and do everything right. The problem is to force our politicians to do that. And we have to keep their nose to the grindstone, so to speak. We have to keep giving them this data, this science. Now, ocean heat content, ocean heating is accelerating. It's very clear. Last year, in 1 year, ocean heat jumped up further than it ever has. The Nature Journal called this an incredible jump in ocean heat. Ocean acidification is also accelerating. Ocean acidification is the highest in 20 million years, according to NOAA. And the scientists have recently come about to acknowledge that actually this rate of acidification is the highest in 300 million years. So you only have to think of these numbers, and also the deoxygenation. These are dead zones out into the open ocean, which are expanding, which are practically, the ocean in these dead zones is practically almost not enough for ocean life to survive. And they're getting bigger and bigger. And overall, ocean deoxygenation is also accelerating. We have an accelerating ocean crisis emergency.
Thank you so much, Peter. The information you just shared is truly, truly frightening. It's terrifying. The idea of these huge leaps in warming. I mean, the living beings in the ocean have evolved over millions of years to withstand certain bands of temperature. And when it goes beyond that, of course, they can't survive. And then the dead zones, I'm certain, have this feedback loop upon the health of the ocean. And then, of course, the acidification, wearing away the shells of various creatures, and then, of course, the effect that has in terms of carbon. It's these feedbacks truly are frightening. Paul, do you have anything to share on this?
Yes. As I mentioned, 93% of the heat of the planet is occurring in the oceans. And one of the things that this does is it causes an expansion of the seawater. And because of the expansion of the seawater, the sea level rise is rapidly rising. Most people just think of the sea level rise as being due to Greenland ice melt or Antarctic ice melt. And those are increasing at ever exponential rates, with a doubling period on the rate of melting, maybe every 7 to 10 years, something like that. So that's adding lots of water to the oceans, also water from alpine glaciers melting. But really the biggest factor in sea level rise up to now has been the ocean expansion because of all the heating. The ocean heating is also really causing some of the largest migrations on the planet of fish, because fish that have a certain tolerance for temperature and their food supply, etc., they're being forced to migrate to actually swim northward to different zones where the water is cooler and is more survivable for them. Also, so all of those things are factors. Also, I mentioned the gases. When you heat up water, it cannot hold as many dissolved gases. That's the opposite to solid. So hot water can be saltier, but it has less, with gases, it has less dissolved gases. So the carbon sink in the oceans is dropping. Also, we can talk about the fresh water that's going into the oceans in the Arctic. A very interesting paper recently showed that twice in the past 150,000 years ago, the Arctic Ocean, believe it or not, became completely fresh water. It was during a very cold period. There were very large, the ice shelves from land extended out onto the ocean up to almost a kilometer thick. So 900 meters of that would be underwater. Global sea level rise was 130 meters lower. So those combined factors basically cut off all the channels to the Arctic Ocean, and the fresh water coming in from rivers and melt, et cetera, made the entire Arctic Ocean completely fresh to deep depths. We're not seeing that sort of thing in a warming world, so that there's some comfort in knowing that some of these abrupt climate transitions in the past were due to the release of all that fresh water from the Arctic Ocean, and we don't have that effect going on. But the Arctic Ocean is definitely freshening a lot, and that has a lot of implications to marine life there. It also, we're moving to a world without Arctic sea ice. That would start in September, minimum sea ice extent. But then, because of feedbacks, that will extend to August, September, October, and then July, August, September, October, November, and then year-round lacking sea ice. And that will completely change the vertical bathymetry of the Arctic Ocean. That will very, very definitely affect the ocean circulation of the Gulf Stream, the AMOC. That's one of the reasons for the slowing right now. So we're going to be in a very, very different climate world. Also, with the phytoplankton are at the base of the food chain. And when you change the temperature of the water, and when you change the salinity of the water, and when that water extends deeper down, the warmer water, then you completely change the amount of phytoplankton that can be in the ocean, and that carries all the way up through the food chain. Also, of course, we haven't mentioned it, but the sea surface temperature warming of the ocean, especially in the Gulf of Mexico and the Atlantic, from Africa towards the US, the sea surface temperature is much higher. And when it's over 26.5 degrees Celsius, then it acts as rocket fuel to fuel huge hurricanes. And these hurricanes move slower because of the jet stream slowing down, and they have tremendous amounts of energy. And because they're moving slower, they can hover around. So just think of the hurricane a few years ago that was in Texas for 5 days. It was half over the ocean, half over the land, and it caused tremendous devastation. So this is a huge problem with sea surface temperature warming as well. The much larger storms, we're getting increases in frequency, severity, and duration of extreme weather events around the world. Thank you.
Well, thank you so much, Paul. And thank you so much, Peter, for this really important discussion. Wow, I mean, you just shared so much. And I think something that you just said, Paul, is really critical. I mean, the importance of phytoplankton to the oceans. To anyone who doesn't understand or maybe perhaps agree that all life is sacred, just imagine phytoplankton. We can't even see it with the naked eye, but without it, the oceans collapse, and then we collapse. So thank you so much for sharing that. And another thing you said regarding the fish migrating northward, it just brought to mind that is what we as humans are doing as well. We're not so different, are we? And thank you so much, Peter, for introducing us to the topic of the the deadly triad of the things and the feedbacks that we're seeing occurring in the ocean, and how incredibly near we are to something that where there's no turning back. And hopefully, you know, your aspirations that we can change it mean that we will. So I hope that you enjoyed this discussion with the Climate Emergency Forum today. If you like what you learned today, please be sure to mark that by clicking the like button, and be sure to subscribe as well so that you'll be notified on future videos. So thank you so much for joining us, everyone.